Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First of all, I'd like to thank the committee for inviting me to chair this second keynote speech session, and also in the second keynote speech today, there will be Dr. Noor Zaman Jhanjhi of Taylor University, Malaysia. Dr. Noor Zaman Jhanjhi, I'd like to read his CV at the moment. Dr. Noor Zaman Jhanjhi has completed his PhD in IT from University Technology Petronas, Malaysia. Good morning, Dr. Noor Zaman.
Good morning.
Nice to see you. Nice to see you today.
Thank you very much.
He completed his PhD in IT from University of Technology Petronas, Malaysia. He has 20 years of teaching and administrative experience internationally. He also contributed a lot in his previous career in Saudi Arabia, and also Dr. Noor Zaman Jhanjhi is the associate editor and editorial assistant board for several reputable journals, including IEEE Access Journal, PC member for several IEEE conferences around the globe, and also he authored several research papers in WOS, ISE Index and Impact Factor Research Journal. And also he writes a lot of books. I got very thick CV from Dr. Noor Zaman, about 30 something pages, a lot of academic history. And also he supervised several postgraduate students, PhD students, master students, and also undergraduate students. And his area is about cybersecurity, wireless sensor network, Internet of Things, mobile application development, and hub network, cloud computing, and software engineering. This morning, Dr. Noor Zaman will be give a speech about the rise of digital twin in industrial IoT and Industry 4.0. He will talk about the opportunities and also the future aspect of the digital twin. As you aware, digital twins have gained significant interest over the recent past, as Internet of Things has become more and more pervasive. In addition, with the development of new technologies such as cloud computing, Internet of Things, big data, and artificial intelligence, the manufacturers are rich in data, which leads to the abundance of new design ideas. However, the manufacturers are facing the problem in efficient designing and risk-free building of product. A digital twin is a virtual model that mirrors a physical object or process throughout its life cycle. So please welcome Dr. Noor Zaman. We will have 50 minutes of speech, and we will end the speech with a Q&A session. We will have about 20 minutes for the Q&A session, and I will invite all of you here to ask questions, to ask more information to Dr. Noor Zaman through chat. You can drop your question to chat window in the Zoom, and also you can raise your hand to speak directly to Dr. Noor Zaman. Dr. Noor Zaman, the time is yours.
Thank you very much, Dr. Ari, for a very nice introduction. So nice of you. I'm just a regular professor like all of our other colleagues, nothing else. So today we are just going to discuss about the importance of the digital technology, digital twin. So just please share my screen. I hope the screen is visible. Yeah, that's great. Thank you very much. So today we are going to discuss about the digital twins technology. As we all are aware that nowadays we cannot live without the technology. And the more aspect is that now the technology is going to be very closer. This is not the time like the 1 decade or 2 decades before, where each of the technology was means independent in one direction. But nowadays, the technologies, they are going to be merged with each other. And then that is the result that we are getting a very high outputs from that as well. So the digital twin technology is actually one of them, which was means is still in a progress, but it started a bit earlier. Almost we can say that means in the recent decade, almost the 7-8 years are the last 10 years. But at this stage, it is working with a very high boom, and still it has a room to improve, because now when this technology was thought that how we can solve the issues and the problems of the design, especially in the manufacturing, and especially for those things which are very critical and very costly, cost in terms of the money, and cost in terms of the design, and cost in terms of the time as well. But now with the time, we are moving with this technology to implement it in the other different applications or the other areas of our life as well. So it is expanding it a lot. So I thought that this is something we need to know about that. So the digital twin technology, we normally call digital twin technology as a device shadow as well. So the device shadow or the digital twin technology is the most important, which can help us to save the cost, to save the money, and to pinpoint about the issues or the problem, and help us to suggest some solutions based on the data, based on the history, based on the current data, and also it can suggest us the future solutions as well. So we will discuss about that, and we will have a case study where we can see, we will have a short video where we can try to understand it, how actually this digital twin technology is working. So going ahead, thank you very much for the brief profile. So everybody is aware about my name. My name is Dr. Noor Zaman, and I'm Associate Professor at the School of Computer Science and Engineering, which is also known as the SCE at the Taylor University. And this is the web link for our profile for our university. And as you described about the books and everything, so this is only one of the glance for the recent books. We cannot include all of the books at this. So this is only just for the interest of the presenters or attendee, whoever is interested, for anyone. So this is only the one glance. So now the contents actually that what we are going to discuss about. So we will try to discuss the introduction about the industrial revolution, or what we call the IR4, so Industry 4. So everybody knows that Industry 4 is a very closely linked with the IoT, which is the Internet of Things. But if we say that it is only the Internet of Things, or it is the only IoT, then it will be means not correct, because it has a very closely link with not only the IoT, but it has a very closely link with the cloud computing, as well as with the artificial intelligence, as well as the other technologies. So as we discussed at the start, that now where we are moving in a way, we are moving in a curve where we are merging the most of the technologies and coming up with the new concepts, which can give us the right solutions in a very right time, with the very low cost, which can be very efficient. How it could be, and why we are claiming that it could be very efficient and very related to the cost matters, that we will be able to understand at the end of the session. And also we will be able to understand that, and we will have the case study, so we can see that how these things are working. Then we will discuss about the IR4 major components, that what are the major components, like what we discussed about the Internet of Things as well, the cloud computing as well, and what are the other cyber physical system as well, other things as well. And then we can see that how these things are interlinked with each other. So the main motive of this is to elaborate about the digital twin technology, and we can see that how it is being used in the industry 4. And also we need to understand that now in this era, if suppose someone is looking to work only in one pattern, one technology, that may not be means very much efficient, but this is now a multidisciplinary research multidisciplinary research era where the different disciplines can work together and then they can come up with the very shining results. So this is one of the examples of that one as well. So then we will discuss about the digital technology or the device shadow to understand, because a couple of the people, they have the different sort of understanding about it, and a couple of the people and the institutes and organizations, they have the different angle about that. But most of them, they are the previous concepts, and now we can see that with the time where it is moving and what it is and how we can conclude it. So if we can conclude it in a simply that we can call it as like a device shadow. So a device shadow, as we can see from the picture, the figure from here, so we can see it's the device shadow exactly for any device. But it is not only an external shadow, but it is a shadow, a complete shadow, which can be means from A to Z. So what it means by A to Z, we will be going to discuss about that as well. So then we see that how it works and why it matters for us. Like suppose why we are considering this. This is the most important. What are the economic values of the digital twin? Why someone can go just only for the accuracy, or there are the other things as well. Okay, and then we see that what are the major applications and benefits are there. So normally there are so many applications, but we will see that for very critical applications we are using this, and we can see that how we are using this. This will be further clear when we will be reaching to the case study, where we'll be discussing that how this can be. So that will be a visualized base that can help us to understand the things. Okay, then we will discuss about the future of the digital twin technology, and the last one is the case study. So here we start now about the background. So we were facing the issue in the maintenance. Say for example, if we consider as an example about the wind turbine. Say for example, we consider for the electric motor. Say if I consider the aeroplane engine. So the maintenance of that one is it was a really issue to pinpoint, to find out the issue means time to address it, and how to address it, in what manner to address it, and how it economically could be a benefit for us, and how we can say that which solution will be more and further reliable for us. So maintenance decision needs to take into account. This was the most important critical point, which actually initiate us to lead toward this technology. So the current state of the component, etc., means systems which are the real time, the cost maintenance and the failure taking the current operation. In case if suppose like what we quoted the example for the aeroplane engine, jet engine, or any other complicated or complex component. So we can see that in case if suppose any maintenance is there, its design phase is there, while we are going to expand it while we are operating and some sort of the issue we are facing, or if suppose we are facing any issue are the challenges in the industry 4, because all of the components, they are linked with industry 4. So how we can overcome with that, how we can know that what could be the right solution, and how we can test the different solutions, and we can see that which solution could be the better one. So most of the things we cannot do on the physical asset, and most of the things previously we were trying to do on simulation based as well. But that simulation based is actually only for the particular part. It cannot provide as a comprehensive solution for the whole system development life cycle for the complete SDLC. But this was the gap which we are addressing, that we are getting help that one using the shadow technology, or using the digital twin technology. So where we can do everything and where we can come up with the right solutions as well. So this is the most beneficial approach which is being used currently in the industry 4 as well, and now it is expanding to the other technologies as well. One of the best example for that one is the 3D technology. So we are going to discuss further about that. So before that, because we are trying to interlink with the industry 4, so that's why we are aware that everybody is aware about the industry 4 revolution, and we know that how many pillars for that one. Initially it was the 7+, then 9+, and now there are the 11+ of the industry 4. So the world is going towards the automation completely. But here we are just trying to see that, regardless of those pillars, what are the major, are the basic components of the industry 4.0. So we can see and how then we can interlink that one with the twin, digital twin technology. So the basic elements of the industries are actually the real-time digital industry and the real-time digital twins interacting, and the other things that how we can, and including the other things like the cloud computing, cyber physical systems, and the cyber security itself. And these are all the things which are actually we need to understand closely so we can be able to get the right benefit by using the digital twin. We can see from here that the Industry 4 is a collective term. It's a collective term. When we say Industry 4, it is not one. That's why this revolution is still in evolution. So what we mean by this, because as we discussed that the Industry 4 revolution, initially were agreed that there are 7 plus. Then we expand it to the 9 plus. Then we expand it to the 11 plus. So we are going to expand it. And why we are going to expand it? What are the basic terminologies for that one, and why we are doing this? So going back to the start when we said that now the world is going to the era where we are having the multidisciplinary research, because from multidisciplinary research now we can get the better results. We cannot say now, like supposed to go only for artificial intelligence, only for cybersecurity, only for the Internet of Things, or only for the industrial Internet of Things, or only for the cloud computing. So now if we just go, so we can find out and we can see that these technologies are multidisciplinary research. They are very closely related to each other. And when we are going with this approach, then we are getting the better results as well. So that's what it means here, that the Industry 4 is a collective term, which is particularly used for the manufacturing. So we cannot say only one technology or something is there. Even it starts from the manufacturing, from all of the manufacturing parts and the processes, and it also goes to the supply chain. Also, it is the part of the Industry 4 revolution. So the related terms, what we are using, which are the basic terms, that is the cyber physical system, Internet of Things, cloud computing, digital twin, cyber security, and there are so many, and it could be expanded with the era as well, while we are going and to further improving it. So these, all of the terms, they originate to the the Industry 4.0, to the most business. But what we are focusing for, we are focusing for its design. We are focusing, what we mean by the design challenges. We are focusing for the maintenance challenges. In case if suppose any maintenance issues are there, we are focusing for the safety and security of the processes as well. So for these, all of the things, the digital twin technology is there, which can help us to rightly approach the right solution at the right time. And where digital twin technology, which we also call the device shadow, we also call the mirroring, we also call the replica as well, these are the different terminologies we use for this one. We can use that and we can pinpoint, and we can also use the historical data. So the data science is involved here as well. So we can use the historical data. Based on that historical data, we can predict some solutions, and we can also run and test that solutions as well. And then we can see that which one is the better for us. So the current usage of the term, when we are calling the 4.0, it actually means if we just consider that this is the only Industry 4.0, then it may not be correct, as why we discussed that there are the so many elements, and it is expanding, and it is, we cannot say whatever the things are, the 11 plus or 9 plus or whatever the things which we just mentioned now. That is, so we know that the technology is expanding itself, but now expanding in a way that they are going in a multidisciplinary mode, where they are merging as well, they are depending on each technology as well, which we also observed during this COVID situation as well. So now we can see that the industrial Internet of Things, what it is. Everybody knows about that. And just for the friends, in case suppose they are just refreshing the idea. So we know the Internet of Things is the network of the items which enables the electronic software sensors, and it works for the network connectivity, and it involves the clouds, and it involves the security, and it involves the automating the things. And this revolution and this everything at the back end is actually the Internet of Things. So when we are using in industries, we are calling it as the industrial Internet of Things. So when we are using it normally, we call it Internet of Things. We are calling Internet of Everything. We are calling, so now a lot of terminologies for the Internet of Things as well. This is the technology which is actually helping us to make the things smarter, to make the things controlled remotely, to make the things automated, to make the digital twin technology as well. So they are very closely related to means each other. So this is how means digital technology can be evaluated or can be used for this one. Now going to the other component for the cloud computing. So in the cloud computing, now we know that this become an essential part. Means now in this paradigm, in this era, everything is going to be, all the resources going to be leading to the means cloud. And especially this is the essential component when we talk about the Internet of Things, when we talk about the IoT, when we talk about the smart technologies, or the smart cities, or the smart concepts. So always we need the support of the component. That's why this is the basic components of this one. So we are using the Internet of Services, as we use Internet of Services, Internet of Everything, Internet of things. So now Internet, it is going with the expanding itself in the different perspective and the different angles as well. So now we understand it, how we are dependent on how it is the essential part of the cloud computing as well for our IoT, and how the IoT is essential for the digital. So digital twin, now what it is, we will discuss, we will come up with the multiple concepts, and with the multiple, why we have the multiple concepts. These concepts are coming with time. We are expanding, we are grooming, we are having other concept, we are having another definition, having another concept for this part. So that's what it is. With time, we are improving in all of the directions. That's how. So anyhow, we can say that digital twins refers to the digital replica. We can call as a digital replica. We can call as a device shadow. We can call as a digital technology. And this means replica, this mirror, this device shadow, it could be for the physical assets, and it could be for the processes as well. It could be for the systems as well. And that could be in real time, and we can use the real data. So this is the most important point, that it is not only for the device, but it could be digital replica, could be for the process as well, could be for human as well, could be for health applications as well, could be for any component as well. So for any component, for any process, for any human, for anything, we can create the digital replica, and then we can be able to analyze it based on the data, and we can come up for the better solution for the design, or for the better solution for the maintenance, and for the better solution for the different aspects of that, whatever the component we are considering. So this is how this is we can call that this is a very powerful approach, a very powerful technology, which is actually enabling us to work faster, and which is enabling us to save our cost and other things as well. Now, most of the people maybe we are not aware this, especially we are not having the more details as the at our university levels in courses and these things for this one, because the basic reason behind that is actually this is mostly involved, and this is mostly in practice, this is mostly in use in the industry side. So this is how that is the most side which is coming. So now from here we can see that there are the different aspects of the digital twin, and even then we can be able to finalize, and we can call it what it is. So we can say that a cross-domain digital model is a digital model, it's a digital replica, it's a device shadow, it's a mirror, it's a copy. So you can see that these all are the different aspects. With the time to time we are learning and we are coming. So digital model that accurately represent a product, production, process, or performance of a product. So we need to be clear about that this is not only about the component, but it is about the production. It's about the process. Okay, as we discussed that this digital twin technology is helping us for throughout the process, for complete entire SDLC. That's why it is very powerful. So we can get the help for the maintenance, for the design for any particular thing, and we can come up with the different things. So we can come up with the right solution. So I hope that from here, from this definition, it can means give us a clear picture that how it is different from the simulation environment as well. Though it is simulated environment is involved here, virtual technologies are involved here. Virtually we can create the model, we can create the mirror, then virtually we can see and we can implement the different parameters and we can see what would be the result. But we can understand what is the difference between the simulation and the digital twin technology. So another aspect is that a near real digital image, a physical means object to process the data to optimize the business performance, which is the most important. Okay, we can use it for optimization. We can use it for the means processes. We can use it for the design. We can use it for the maintenance as well. See, another aspect, representation of a physical assets that has a level of the completeness and accuracy, and it includes the context information. So it includes all context information, and it can help us to to make a proper replica where we can test the things. So we can see from the other aspect, the digital twins are the virtual replica. So the physical devices that scientists and IT professionals, they can run simulations before actual devices are going to be done. So here we need to understand about the difference between the simulation and the digital twin, that you can be able to understand completely clearly when we will be having the demonstration, the short video. So now from here we can see, if we conclude in short, the digital twin concept means combines the ideas of modeling and Internet of Things. So why we have the different versions? These different versions, as we discussed it now, the technology is working, merging with each other, and we are expanding in the multiple directions. So now we can call digital model. Later we understand, yeah, it could be a completely device shadow. Then we can see that it can work for the for the whole SDLC, for the process, for the physical assets. Then we can learn that it is not only for up to the industry 4, but it can work in the other domain or other application areas of our life. And this is a real-time model where we can utilize our past data as well, the history data as well, and then we can even see what could we do right now and what we would we be able to predict in the future aspect as well. So we can see the digital twin further definitions. So you can see digital twins refer to the computerized companions of the physical assets that can be used for the trading. So if you just go and you find there are the different sort of the definitions. So what it means by the different sort of the definitions, these all are actually with time to time, with improvement, where we are looking, where we are going, what we are achieving based on that, our achievements, the definitions, and these terminologies are with day by day. So you can see digital twins use the data from the sensors installed on the physical objects to update the representation of the reality based on the mathematical and statistical model. So now you can see we are bringing the cybersecurity, we are bringing the IoT, we will be bringing the artificial intelligence, we are bringing the statistical and mathematical models, we are bringing together to the data sciences as well, we are bringing the virtual technology as well. So you can see that how we are increasing the dependency of the multidisciplinary approach and multidisciplinary technology. And why we are doing this? Because you will be wondered to see that what results it brings for us. So this is what is the future direction of the technology. So the digital twins is meant to be an up-to-date, accurate copy of the physical object properties. Means not only the physical object shadow, but it has the complete object with all of the properties of it. Okay, all of the characteristics of it. And it is state including shape, position, gesture, status, motion, means a true copy, a complete mirror, you can call that one. So that's why we can go at any level and we can see and we can fix accordingly. Now, again, further, we can see that what's the digital technology. So if we just continue, we will be having the different versions of the definitions. When we will go in literature, we will find that these definitions are belongs to the different timings. Okay, but why we are explaining all of them to get the right position, to get the right understanding about the digital twin technology, and also to understand that what the technology curve is, where the technology is leading is. So what we can decide our direction for the future perspective, where we can be looking for the multidisciplinary approaches, work jointly with the different technologies in the course. So this is the comprehensive replica, accurate representation. Yeah, we already discussed about that. And it is the advanced analytics and machine learning. So now you can see that how the means the different areas, statistics, historic and real data, technically business operations and context dependent. So why we include these all things? Just to give a message to see this is something which is going to be a merger of the different technologies. And then when we're doing this, so we can see what a wonderful means, what a significant results are of what we are getting as well. So now how it is working means what it is and what is the process for this one actually. So we can see that we have the process, the steps 1, 2, 3, 4, 5. So in the step number 1, we connect and collect. And number 2, we learn and analyze. And number 3, we means alert and advise. And then number 4, help us to decide and optimize. And finally, number 5, it is the innovation and the transformation. So these all are the steps. Like suppose we connect with the data, we learn and analyze based on our previous data. Okay, for any component, for any physical component. When we are referring to the any component of the means existing data, what we mean, say for example, the case study what we will discuss that will be related to the means jet engine as well. So if suppose we are having an issue, a wear or tear or something inside the means jet engine, so how we can be able to come up with the right solution, not only based on the current condition or status of the problem or issue what we are looking for, but because this issue maybe our aeroplane is in service since 5 years, 10 years, 20 years, so we need to see the history of the data, that why we reached there, what could be means the causes why this problem means rises here. So now when we are going to suggest something, so what problem we can address, so the issues based on that problem was arises, that may not be means going to be repeat again. So it's a wonderful, thing that you can see from the number 3 that this is the alert and the advices, and then we can go to decide and optimize. So we will have the decision options as well. So on that we can decide, we can optimize it, what it could be and what is the right solution for us. And then we can decide what could be the innovation where we can be looking for. So we can see that how we are doing. This is only a simple diagrammatic model. So where we can understand about its importance. So we can see that if we suppose I make a pointer, so it's easy to understand. So pointer, so we can see that this is our number 1 is the physical. So now this is our digital asset. So you can see this is the completely same, and now this is the real-time data. So real-time data and the previous historical data as well. Based on that, we can do the analytics, and then finally we will be able to speak to the solution. If we just go back, so we can see from these all of the steps that what we used. So in this approach, we are using our previous data, our current data, and then we are using the different technologies, and we are using the different options, and then we are able to come up with the multiple solutions. And then from the multiple solutions, we can be able to choose the right solution for us. So you can see this is the how the replica. So this is one part is the physical, and this is the digital part. So in physical part, we cannot do any alteration or moderation, and then we can see that how and what change in it. But in the digital part, we can see, and then we can see that what could be after doing this or what we're considering these changes. So what will be the result? So we can examine that. We can have those details as well. So once we get satisfied, then only we can come back to the physical assets, and we can make the changes for this one. So this is the further detail perspective for that one, how we are able to look for the physical and how that one. So you can see from here. So this is the create and communicate and aggregate and analyze, and finally we see the standardize, and we see the inside values, and then finally we can be able to act at what would be a solution and what would be our right solution. Not only the solution, but we can see that what would be a right solution. So now from here again, you can see that what are the technologies and what are the unique things what we are using in the digital twin technology. A lot of things, models, we are using 3D models, we are using the process models. There are a lot of assets. We are using that one as well. Then we are using about the data, the safety process, and the environment, and the analytics, these things as well. So These all are the means we are involving. That's what we are focusing from the start, that we are using the multiple technologies, and then we are able to get it done. We are able to understand the things, and we are able to means deploy this one. So now emerging generation of the digital twin enabling. We have the digital models, data acquisition, and then analytical tools. So the first one is the digital model, but this is actually based on the data acquisition. What data we are collecting, real data, runtime data, the past data, what could be the future is predictive, and then we can analyze the data. Based on our analytics, we can come up with the right solution for the right model. And how, and these the current technologies we are depending on them, or we are including, or we are using them. So we can see that IoT, machine learning, cloud computing, edge device technologies, simulation technologies, big data, 5G communications, cybersecurities, virtual technologies. So means there are so many things which we are depending, we are involving, not we can call it depending, but we are involving them for the better results to be achieved. So this is how the process is. So the building model, again, the building a model, connect and collect, analyze them, and execute, devise them, and then we will be able to reach to the innovative. So the performance of the digital twin is very wonderful. Why it's very wonderful? Because when we analyze the data, when we execute and optimize the solutions in our digital environment, so at that time, the digital technology approach also suggests us that if suppose we go for this one, so we can be able to examine that what could be the results, how long it can go, what sort of the economical benefits we would have. So we can have a very clear picture, not only for that particular target, but we have our own complete clear picture about the whole process SDLC. So we will be knowing that at what level, what could be, means where could we will be able to strengthen the things, and where we can be able to means come up the right solution as well. So this is something we can call a really means fantastic in the technology world, fantastic solution for the industry, for our industry revolution 4. How it works means convert different technologies, and then we can use the past data, and then we can analyze them, and then we come up with a solution, and then we can see that what would be the right solution for that one. Now, initially, it was actually means focusing, targeting to solve the critical issues of the design and maintenance for the industry. But now, if we see that these applications are expanding, as we discussed earlier, that these things are expanding with the time and very much expanding, we can apply now for at any means level. So it is now in manufacturing, automobiles, aerospace, healthcare, wind farms, retail services, mobile means oil and gas area fields, turbines, electric motors, and the other infrastructures, physical infrastructures. So now it can be doable even means for the human, for the health, and for everyone. Are not involved. That doesn't require to involve the cost. And while we are going for this one, when we are going for this one, it is means using our past existing data as well. And then it means suggesting us the right solution as well. So based on that, we can see that it is suggesting us the different possibilities that how we can go, and what option if we are going to choose. So then what could be means the economical values for that one, and how reliable that solution will be, and how long that solution can lead, and means why and what other components could be means having any impact on that if we suppose we are choosing any of the option or anything else. So this has the right solution, where we can see that it helps us to come up with the right design, right maintenance solution in a very economical way for the cost saving, and in a very economical we not only related to the cost, but it very economical and related to the time aspect as well. And it very work and very worthy for the very complex solutions as well. That we will be further discussing. And so you will be having the case study that will be means giving you the more clear aspects about these things as well. What are the benefits? We already discussed about that. There are a lot of benefits. We can improve the quality. We can improve the quality. We can do the modifications. We can do the maintenance. We can do the pattern design. We can increase the efficiency of the means of the industry, any process of any components of the robotics, whatever the components and what we are going to apply for the digital technology. We can reduce the operational cost. This is the most important point as well. Not only the cost in terms of the money, but we can optimize it. We can reduce the timing as well. We can optimize the robot operation management as well. We can reduce the cycle time and boost productivity as what we discussed. And we can exactly means diagnose the means any failure is there, and we can exactly be able to fix that one. So that is the digital twin technology, which can help us. We can say that it is the major backbone, is a major means component which can be means helping us for the IR4, which is the very important one. Beside of that, means other things as well as we discussed, but we are focusing mainly about IR4 because today's our focus and aim is related to the IR4. So it has a lot of benefits, like including from the yield, from the improving process, optimization, cost saving, efficiency, and so many things as well. So now if we just have a few means glimpse of the pictorial graphs and analytics from where we can be able to understand that what is the importance and how the people are. I can see fine as well. So sorry for that. We'll be trying to speed up to finish it up. So we just try to see for the pattern trends that how many applications are filed related to the digital twins in the industry and in other aspects. So from here we can see that these are the trends. I will just go a bit quickly because our demo itself is for 10 plus minutes. So we are only remaining is the 20 minutes. So sorry for that. We just go for the speedy and to cover the time. So this is the pattern trends. So we can see that what are the means giant companies, General Electronics and Siemens and Tesla Metals and Microsoft and the Honeywell. So how many patents they means filed for related to the digital technology, the recent past for the last 4 or 5 years. So we can see that the non-practicing people as well, even from the universities and from the research centers and from the research labs, they also means participated for this one. So the world is focusing for this one. And this is the right direction as well. So the world is looking more than beyond the industry 4 as well. So in the same way, we can see from here, the other application analysis. So we can see this is mainly it is involved in manufacturing. So that's why we are focusing on the industry 4. So you can see the most part is in manufacturing, automobiles, aerospace, healthcare, infrastructure, industrial IoT, wind farms, and the entertainment. So this can give us a right idea that now this is not only limited to the industry or manufacturing, but it is means in all of the other areas. The more aspect from here, so we can see that what are the trends and where we are. So we are just going a bit speedy. Sorry for that, just for the limitation of the time. So we can see the other aspects with the general electronics versus the applications. So this is how the different trends are, and these trends are for the last 5 years. In the same way for the Siemens and the versus the other application trends. And going ahead, we can have the further technical analysis of how we are working and what we are involving, like suppose for the monitoring or testing, for controlling, and how much we are dependent on the data, for the past data, and what are the other things. So we just try to come up with the analysis part and how much we are depending on that and how we are handling that one. So digital twin technology, the examples, we reach to the examples. So there are so many examples like we noticed from the applications as well. But the best example is actually the 3D modeling, so which can be creating a physical object based on this could be the basics. We call this as the device chain as well. Anyhow, the other applications we are using for the monitoring purposes, we are using for the design, we are using for the maintenance purposes, and we are using for so many other sort of the applications as well. So now this is the aircraft engine. Our case study is related to the aircraft engine, and in this particular case study, we will be able to see actually to learn the power that what is the digital twin technology, and then we can see that how it is involving the other technologies and how much it has, and how it is grooming, but already at this stage, how much it is involved in our industrial processes. And then the wind turbine as well, but because of the limited of the time, we'll just discuss the one case study. So here is the case study I can show you, and this is even a couple of years before. So if maybe I need your help to run this one, yeah, it is okay. So I hope that you will be able to have the voice, because that's the most important. Before I just run, so please, please let me know that I'm able to have the voice. So are you able to have the voice as well? Because that is the most important. Anybody can confirm that? Are you able to have the voice as well?
We can see the video, but not the
voice.
Yep.
Yeah. So for the voice, I'm not sure that probably maybe I need your help.
Or we can just drop the link of the video, Dr. Noor Zaman, to the chat room so that our participant can have a look at the video. It should be all right.
Okay, okay, then it's okay. But maybe in the settings, we may have an option, I believe, from where we can go for the option for the audio as well. So just give me the 1 minute. Maybe I can microphone system as same as some speaker. So probably we can be able to provide this one now. Yeah, we will also provide the link as well. Is the voice coming now?
I can't hear anything from the video.
That's good. That's good.
Probably you need to share the sound in the share screen settings.
You are not able even to hear me like that?
I can hear you, but not the video.
You cannot see the video?
I can see the video, but I can't hear anything from the video.
Okay, no worries. Then I will just explain about the video, and then we will place the link there so everybody.
Sure.
Thank you, and sorry for this technical aspect issue. So this is actually a video. We can take a little time. So this is how the digital technology concept, digital twin, technology concept. So they are considering the jet engine. So here is the. So here the digital twin technology is having a problem. So now he's asking that what is the problem? I just help me. Now digital technology is actually letting to update that. Sorry, update about the whole details that these are things since last 6 months. So I'm facing this issue now. Is asking that let us know what is the damage right now and where it is, and what is the severity about that. So the digital twin is replying and showing that this is the point where this is the issue, and this is increasing. If you will not take it, then in the next coming, this will be stop the working. So now he is asking that just provide us, suggest us any right solution. So now the digital twin technology is suggesting the two solutions. So the solution number 1 and solution number 2. Yeah, so you can see the further from this one. So now he's asking that what factors do you involve and calculate for the option number 2. So now the digital twin is explaining that he used the last 15 years data, and also he ran the 58,965 simulations, which is a huge number for the whole process, and come up with the right solution. Now he's asking that means why I second. So let us know that what is your severity and what financial aspects and how I can go for that one. So now the digital twin is letting them know how much cost it will be involved and how we can go for that one. So now he is suggesting that go for the option number 2 and just go for to initiate that one. So now based on that analytics, now what happened, this is actually going to use that option and come up based on the data of the current and the last 15 years data and 58,900 something whatever the simulations done for the whole process, and then it is suggesting a solution. So based on its choice, it is going to go for that solution, and then again digital twin will analyze and it will advise it what could be the results after that one. So this is how then it will be implemented to the physical part. So this is how it is digital twin technology is working. So for the future, as we know, maybe I just only need 1 minute, 50 is almost there. So in the future, as we know that everything is going towards the Internet of Things, and more than 85%, the people are looking for the digital technologies, automation and smartness of the technologies. In the past, the people were looking for the smart homes, then also for the smart cities. But now even there is a concept for the what we call the smart society as well, which is the Society 5, also known as well, where we are hoping and focusing for the all of the things to be automated. So this is the future where we are looking for. Thank you very much. This is how what we discussed for the digital twin, its shadow technologies and its revolution. And technology can help us to overcome so many things, and we need to equip ourselves with the further with the technology, and we can see that how we can involve multidisciplinary technology to come up and address our solutions. And these are the different references what we consider, and thanks to them, everyone. So thank you very much. I hope I try to just to go one more. Thank you very much. So nice of you. Thank you.
Thank you very much, Dr. Noor, for the wonderful lecture this morning. Ladies and gentlemen, we talk about the digital twin, which is we can call it digital replica, and also several other names. Here, speaking mostly about how we minimize the risk and also providing sort of like environment which is safe to train the system, environment to test the parameter, and also we see a lot of cases presented by Dr. Noor Zaman this morning. There are a lot of company having the benefits of digital twins, like how the GE, we may aware that GE producing the airplane engine, so that to minimize the risk of new technology, probably they apply the new configuration, new technology over the digital twin. Also, if we try to find information about digital twin, we can get like an example of case, I think, like Sydney Opera House also benefiting from digital twin, and a lot of other case. And to summarize, digital twin have 1, 2, 3, 4, 5, 6 steps, I think, The first one is to connect and collect the data, I think, and then learn and analyze, alert and advise, decide, and building innovation and also transfer. So we are now in the second part of this session. We are having several questions in the chat window at the moment. And also, we are inviting you to raise your hand if you want to ask question directly to Dr. Noor Zaman. Meanwhile, I'll read the first question from Noor S. Trila. About the education sector. Will it beneficial for the education sector, Dr. Noor Zaman? And please, if
Yeah,
you
thank
have
you.
example.
Yeah,
about
thank you
that.
very much. Thank you very much for this question. Yeah, it could be very beneficial for the education, especially if we consider the complex engineering solutions, where we can explain in the digital environment, digital twin, using digital twin solutions for the engineering, and also it can be very helpful for the medical and the complex solutions of the human body parts as well. So this could be a beneficial for this domains areas.
Okay, thank you very much.
Welcome.
The second question is from Dr. Ridho Rahmadi. Do you think the digital twin will face the issue of ethics in the future? Since we also know that digital twin used as well in health sector, right? So will it be problematic in ethical way, Dr. Hussain?
Yeah, thank you very much. In ethical aspects and in a privacy point of view, these are the equal challenges for our future with the growth of the technology, parallel to the security as well. These ethical issues are already, means there are so many concerns over the artificial intelligence technology as well, where we are using in more of the different aspects as well. So this is the means another side of the coin, but we can say that the related to that ethical issues when we are focusing and discussing to the health technologies. But when we see the other side of the coin, this will have right benefits, right understanding, and right solutions as well. Say, for example, like what we quoted the example in the case study, which can have the comprehensive means analytics, and then it provided us the comprehensive solution. Why we are calling a comprehensive? Because it ran actually more than 58,000 simulations for that particular part of the engine. So in case if suppose we are applying it in health for the damage of the bone, or for the knowing the strength of the bones and everything. So if we use the digital twin technology, this can run the different simulations, and it can come up with the right solution that why we reach to the patient at this level, at this stage, and what could be the possible solutions. So it can analyze in a better way. But there is, at this stage, if suppose we say that there will be no completely ethical issue, this may be, we will not be correct in that statement. Like same, if suppose we go for the UAVs or the drones technologies, there the ethicals and the privacy issues are very much. It is growing a very high scale nowadays, but there are the so many ethical and the other privacy issues are like suppose, sorry for that, and they are means flying in the cities, and they probably we don't know that these are the commercial flights, or these are the governmental related. Maybe they are taking the pictures, doing something. So in the same pattern, the ethical issues with the growth of technologies are there. But when we see the positive pros or perspectives, then it is more important. Thank you.
Thank you very much. There are several more questions. The next one. Will the cybersecurity making a significant to the digital twin, Doctor?
Cybersecurity is very important in all of the aspects, not only in the digital twin technologies as well, but the cyber technologies are having a very right and direct impact on the means each and every technology what it is involved in it, including the Internet of Things, including its the processes and AI and everything. So because these technologies, what we are using, we are adopting, we are collecting the data and everything involved in it. So cybersecurity is, that's why it's a very much emerging, and that's why while we notice when we discuss about the technologies, so if we just focus on this slide, so in this particular slide, we can see that the data acquisition and everything we are doing, they have its particular role, but when we are reaching to the cybersecurity, so we can see it is having a very expanded role. Thank you.
Thank you very much. Speaking about the data, Dr. Noor Zaman, is there any requirement, or do we need to like having a real-time data pipeline, or we can process the data between the physical and the virtual the assets? Is it do we need to have a real-time data, or we can process the data in batch?
Okay. We need to see the digital twin technology with the different aspects, the two major aspects. One aspect is while we are looking for the maintenance, we discussed about the case study. In that case study, we have the real-time data and the data what we have from our past as well. The other aspect, while we are going to design some new component, and we are involving for the betterment of the design. So in that time, if suppose we don't have the real data, then it doesn't matter at the same level, but where we are considering the maintenance part.
All right. Our last question from Dr. Muhammad Andri Setiawan is about how we are confident with the real virtual. Is it really real, so that we can use it as our model? So how to ensure all the model or the virtual assets is representing the real one?
Yeah, that's very nice question, because we cannot cover up within the 1 hour. So we can see that how this technology is implemented or being created. So there are Six Sigma and the other tools in the softwares where they are implementing. So they are making a 100% real replica. That's why we are calling this as the device shadow, completely shadow, which is comprehensively covering all of the phases, all of the SDLC, the minor and minute details as well. So this is the real copy of that one. If suppose we don't have a real copy, then we will not be able, whatever the solutions we are suggesting, to be reliable at the same level. So this is the real, and we can trust on that. The other thing is that how we can trust on that. We can trust on once the product is there, once we have the results, once we have its use in our real life. So this technology is being used since last 4 or 5 years with the Siemens and with the General Electronics and with so many huge companies in US, and they are involving in the jet engines. They are already using in the wind turbines. They are already using in the electric motors. So their accuracy rate is more than 99.9%.
All right. Very last question, I think. Yeah. For oil and gas, there are very huge data, right? How to make it possible to use digital twin in that sector, Doctor?
Yeah, for oil and gas, actually, we have a chain of operations. The operation where we are looking for the first of the component where we are looking for to pinpoint to find out where the oil and gas is available. So first of all, we are looking for the availability. Second option is then once we have the availability, then we are going to start digging and utilizing them. Then the third is the transportation level. So this is how when we are discussing about the oil and gas, so we can see that at what component we are looking for, in case especially for the part A or the phase A or phase 2 or phase 3. So in any of the phase, it can help us to give us the better design, to improve the design in case if suppose we are having issues with the design, which is with any design we are not successful or we are not getting the results for finding any solution. So this can improve and optimize the design, which can help us to pinpoint and find out the island and the solutions.
Thank you very much. Ladies and gentlemen, we are run out of time. So I hope all the answer can provide good information for you. Thank you very much, Dr. Zaman, for today's presentation. And also I hope this area will grow vastly. And also thank you very much for the committee. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you very much.
Thank you very much.
Especially for your timings, and thank you very much to Professor Rio, and thank you very much to the committee and the team and to the university for providing this opportunity and chance. I hope everybody get from this. So nice of you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you very much.